Okay guys, I'm going to re-audio the new system. Okay, so this one is the 2015 paper and we're going to do a zero point 0.5 speed, okay? Now, what we have for us is if particle starts from rest and moves with constant acceleration, the particle travels 39 meters in the 7 second, find the distance traveled in the 10 second. Now, what written down there is S6 and S7. S7 is the distance covered in 7 seconds total, and S6 is the distance covered in 6 seconds total. The extra distance that S7 travels will be 39 meters. Because in the 7 seconds you travel an extra 39 meters, okay? So this blue line represents the 39 meters. So what we're going to say is that S7 minus S6 is going to be 39 meters. Okay? Now, for UVAST, okay, what we're going to say is that the particle starts from rest, so both are 0, okay, and we're doing it for t equals 7 and t equals 6. The a values are the same. The t values are 6 and 7. That should be not not 6 and t. It should be t equals 6 and t equals 7. And we're going to find out what S7 and S6 are using ut plus a half at squared. S6 is 0 times 6 plus a half times 6 squared, which is going to be 18a. S7 is going to be 0 times 7 plus a half a times 7 squared, which is going to be a half of 49, which is 24.58. Now we know the difference between the two of them is 39. So we're going to do S7 take away S6, and we're going to find out what is the a value. Okay. So then we got 24.58 take away 18a equals 39. 6.58 equals 39. A will equal 6. All right. Now this brings me on to the next part, where I'm going to have to find out how far it travelled in the 10 seconds. Now to find out how far it travelled in the 10 seconds, it's quite simply S10, which stands for the distance travelled in 10 seconds, take away S9, which is the distance travelled in 9 seconds. Okay, once again we're going to use ut plus half at squared, okay, for both data sets and an acceleration value of a. Now you should see me, we're going to rub out all this workings from the earlier question, and now we're going to redo it for t equals 9 and t equals 10. 0 times 9 plus a half, 6 times 9 squared. Okay. And then we get a half times 6 is 3. 3 times 9 squared is 243 meters. The next one's going to be 0 times 10 plus a half, 6 times 10 squared, which is 300 meters. And basically, S10 take away S9 will be 57 meters. This means you travel 57 meters in your 10 seconds. Okay, next thing. A train of length 66.5 is traveling with uniform acceleration 4.7 meters per second. It meets another train of length 91 meters traveling on a parallel track in opposite direction with uniform acceleration 8 over 7 meters per second squared. Their speeds at this moment are 18 and 24 meters respectively. Find the time taken for both trains to pass each other between the trains 1 second later. So here's what we're going to do. Imagine the red train is train A, blue train is train B. And what we're trying to figure out is how much distance does it take for all of the red train A to pass the blue train B. Imagine the blue train was stationary. Okay? Imagine that it just wasn't moving at all. Okay? And you're at this point here. The red train can bypass the start of the blue train there. Alright? But it still has to bypass the end of the blue train. So we have to find out the distance it's going to take for it to bypass all of the blue train completely. Okay? So what's going to happen here is we're going to imagine there's somebody at the end of the red train and there's also somebody at the end of the blue train. Okay? And we're going to do the distance it will take for both of them to get by each other, right? So what we're going to do is we're going to move the red train by the blue train. That's what happened in real life. They both pass each other out, but we're keeping the blue train stationary to make it easier. And then we're going to put it down here. Okay? Now the red train travelled this much distance here. And what is this green distance equal to? Well, it's actually equal to the length of both trains combined. And there goes that's how you do this question. The distance both trains have to travel is equal to both their lengths. So S1 and S2 combined will equal the lengths of both trains combined, which is 157.5 meters. You're going to do two separate UVAS systems using the distance, using the criteria applied. You don't have to worry about the fact that they're going in opposite directions. All you need to know is that their total distance is 157.5. So what you're going to do is you're going to make a UVAS system for both of them, and you're going to list off your 8 over 7, your 4 over 7, your t values are the same because they both start at the same time. We're going to use ut plus a half at squared for both data sets, okay, and for S1 and S2, and there it is there. And then we're going to obviously multiply that out and get 18t plus 2 over 7t squared plus 824t plus 4 over 7t squared. Then we're going to add both of these together. Add both of them together, we get 42t plus 6 over 7t squared equals 157.5t. We're then going to move it all over one side to form a quadratic equation. This use the minus b formula to do this. I'm not going to do it here. No point, but you should get a t value of 3.5 seconds if you remember anything from this morning, which is a rarity. So just do the minus b formula, you get 3.5 seconds. Now, in the next question, you're going to have to do it for 1 second later. Now, don't just do it for 4.5 seconds. Start it from scratch again, okay? So I should do a diagram to make this a bit easier. There's the red train, there's the blue train again. This is stop the clock here. That's after 3.5 seconds where the blue train and the red train have just cleared each other. And then what should happen is both trains move away from each other and there's a new distance. That's the distance between the two trains 1 second later. What we could do is we could put the t value equal to 4.5 and then just take away the 157.5 meters that we had at the start to find the x value. Okay? Because both trains travel 157.5, it's what additional distance they carried over would be x. So we're going to use the same formula as above. We're going to use 18t plus a half 4 over 7t, 18t plus 2 over 7t squared, and 24t plus 4 over 7t squared, etc. T value is going to be 4.5 this time. Okay? The fact that it's 4.5 this time means we're going to have a bigger number than 157.5. We're going to add the two of them together. Do it separately even. This smaller train travels 86.7857. The larger train, faster train, travels 119.5714. Then we're going to take away our 157.5, leaving us 48.875, and we're done. Okay. Sorry about the original audio. I'll just redid it there. Okay.